there is a lot more that we can do with Excel than just these like the simple data validations and this ETL. There are lots of add-ins in Excel, and it can help us with different things. And that ranges from statistical analysis to regression models. I'll go to Excel, and you will need to install some add-ins for this one. If you go to this part of Excel, like when you open it up, you can go to this option, add-ins. And then in this add-ins, if you don't see this Analytics ToolPak, you will see this Analytics ToolPak in the inactive application. So you just need to click on that. And then you can just say, for example, I think I'll just do go. And then I will just click on the ToolPak that I want to add, right? So I need to tick on this Analysis ToolPak because that's the one we will use now. And then you can tick this solver add-in as well, but yeah, that's not necessary. Just make sure that you have got this Analysis ToolPak, okay? And then just press OK. And it will add that Analysis ToolPak to your Excel. And once you have got that Analysis ToolPak, then I can just open a new workbook. And then if I go to my data tab, I will get this data analysis option here. So just make sure you follow that step and check in your Excel. Okay, while it is loading, I will just give you a quick overview of what it has got. So if you click on this data analysis, you can see these are the things that are available with this data analytics toolpak. You can do ANOVA single factor, you can do ANOVA two factor, you can do correlation, you can do covariance, you can do descriptive statistics, you can even do like exponential spooling, F1 test, a Fourier analysis, all these things, right? And we probably won't care a lot about all of these, but these are some of the statistical tests that we will study in our statistics section as well. And then when we are doing that, we will come back to Excel again and do these tests from Excel, right? Because what we need to learn is how to interpret those test results. We don't need to worry about how to calculate this because Excel can do it for us or any other tool can do it for us. What we care about more is how to interpret that result. So to calculate this test, to use that test, we will just come here and do it. But when it gives us that statistics, we need to be able to understand what this means. Does a negative one means good or does the positive one means good? So we use a lot of correlation, covariance. We definitely use descriptive statistics. We use some F test as well. We will use T test as well because that's part of our thing. And we do regression a lot. And while it is loading, you can probably start working on this as well. So let's create some random variables X and Y. And I'll just use this function called rand, and it just gives me a random number. And that random number will be between 0 and 1. So I'll just create some random numbers for Y as well. And there you go. I have got a bunch of random numbers. One cool thing about Excel now, especially the updated versions of Excel, you can find this analyze data option. And it is really good, right? So when you load the data into Excel, you just click on this one and it will start to give you suggestions about what are the things that you can do with this data. You can do a scatter plot, which is pretty nice. You can do frequency of X, you can do frequency of Y, which is the histogram plot as well. That's really good. I can use a line chart of it. It understands what the data is and it would suggest these kind of charts, and it will even suggest tables and all those things, depending on what data you have got, right? So it will just help you generate some ideas. Okay, so now let's try to use that data analysis toolpak to do some of the things that we usually do as a data analyst. So first thing you will do as soon as you get the data is you will try to explore that data and you will try to get some statistical numbers about that data. What is the mean of this data? What if the spread looks like? What's the standard deviation? What's the median? And what are some other things, some descriptive statistics about this data? So if that's the case, then what I will do is I will select the data that I'm interested in. I'll go to my data tab and I'll click on data analysis. And I will select the descriptive statistics because I'm curious about what the statistics for this data looks like. So I will click on descriptive statistics and I'll press OK. and it will tell me what's my input range. So I'll give it my input range, and I will tell it that my first row is the name of the column. So I need to tick here saying labels in first row. And then, I want this to be on the new worksheet. So the descriptive statistics, it will put it in sheet. And I want the summary stats. I want the confidence level of, I can just do all of that. So I don't care. Let's just give me everything. And then I'll just say press OK. And what it did for me, it gives me this table, which is a really nice descriptive statistics for this variable. So I know exactly what the mean of this variable is, what the standard error, what the standard deviation is, what's the kurtosis, what the skewness, all these things, it tells me about this data. And it is pretty handy because it's not like you can't calculate this by hand. I can go in here and I can do those things, right? So I can just do equals, average, and I can just select these numbers and I can calculate the mean, right? It's no big deal. And if I want standard deviation, I can do a standard deviation, and then I can just do this, right? So I can just select the data and it would give me a standard deviation. So it's not a new thing. We can still do it using the formulas, but it saves us a lot of time. We just use that and it gives us everything that we need in one go, right? And not only that, we can do a lot of other things like the options that we see here. So what if this was X and Y and we want to do a linear regression on it, right? So we want to fit a line against it and see if that works well. So in that case as well, we can use the data analysis, and maybe before regression, let's try to do the correlation analysis, because we want to see whether these variables are correlated or not. And only if these variables are correlated, that's only when the linear regression would make sense. If they are not correlated at all, we shouldn't worry about creating a linear regression, because there is no correlation cause the linear regression won't work. So let's try to get into correlation. So correlation is the input range, X and Y. And yes, I have got labels in the first row. So always remember to tick that labels in first row if you have selected the column headers as well, because it will not work if the data is non-numeric. Because if the data is non-numeric, you cannot perform those mathematical operation on it. So you can select the column names, but you always have to tick this saying labels in the first row. So it skips the first row and treats it as the name of the column. Right? And then I'll just say, okay. And now it just gave me the correlation. So it is saying that there is a really weak correlation and it's at minus 0.24. Any value that is closer to 1 indicates higher correlation. Any value closer to -1 is also a higher correlation. If the value is close to 0, then it indicates low or no correlation or weak correlations. So in this case, the correlation is negative 0.24, which is indicating that there is not a strong correlation in this, which is what we expect, because these are just two random numbers and we don't expect two random numbers to be correlated. Right? And that's what we're seeing, which is exactly what we expect. Right? But let's try to make them a little bit correlated. Okay, so we'll introduce something in here. So I'll introduce the coefficient called M, and that M will be 3.5 plus So we'll go in here and we'll insert another one called error or E. And then that will just be random. So that will just be another random. And now Y, what I want Y is I want that to be this times this plus. And why I'm doing that is I'm trying to model a linear regression where I have a formula that looks like this: Y equals mx plus E1. And that's why I'm trying to build that synthetic relationship myself so that I can make sure that these X and Y's are correlated. All right, so I'm just trying to build some correlation between those two. And now let's give it a try. So now let's try to select this and go to data analysis, and let's do a correlation analysis on them. So I have to select all of these and labels in first row. Let's put it into a new thingy. So now let's have a look at X and Y. They are still that much correlated, I think. And let's make it well, a bit more correlated again. I don't need to worry about that. So I'll do correlation. And here again, these are selected. Want it into the new sheet. And there we go. We have got a correlation, but that's fine because this is what we are trying to do. Y equals mx plus e. And if I take out the randomness from here, would that change this one? Okay, I don't want them to be perfectly correlated. That's why I was trying to mesh. So that's how we will look at the correlations. And once we are happy with the correlation and there seems to be like some sort of a relationship between those variables, that's when we will start to build our regression model, right? So what I will do is I will again go to the data analysis and I will find the regression and I'll press OK. So on the regression, we need the input Y range. So the input Y range is 1 and input X range is this X here. And then I have got labels. And now what I want to do is I want to look at the line fit plots, and I probably don't care about other plots. So I'll just press OK. And it's this easy to create a linear regression model, right? So you tell it what the Y input is, you tell it what the X input is, and then it will be able to create that linear regression model for you. It's as simple as that, right? You just need to know how to use this tool. But after that's what the things get tricky. So once you have built the regression model, you at least need to be able to explain whether this model is performing good or not, because that's your primary responsibility as a data analyst, is to be able to say whether this model is good or not. Anyone can build these models now because all it took is just 2 clicks to build this model. But what does that mean for data analysts? And what that means is a good data analyst needs to be able to interpret these results and tell them whether this model is good or bad. So let's have a look at this. I'll show you how you can tell whether this is good or bad. So we need to look at all these things. Okay. So what are the things we look in linear regression? And again, I don't want to get into all the depths of linear regression now because we have got a dedicated section for linear regression where we learn about all this, what the p-value means, what sort of things we need to look out for, all those kind of things. So the thing that I will look for is R-square value. And R-square value needs to be as close to 1 as possible. So that seems really low for me. So that kind of tells me that it's not a good model. And other than that, I will also look at the p-value. So p-value, and I'm more interested in the p-value of the X, which is telling me what is the contribution of value X to the final value of Y. And it seems like they are not correlated at all because the p-value is really high. The kind of p-value I'm looking here needs to be below 0.05. So if you convert that to percentage, what this is telling is that there is a 92% chance that this relationship that we're seeing between X and Y occurred by chance. That tells you that this relationship is really bad. This regression model is bad. But if that percentage was low, when I said lower than 0.05, what that translates to is that there is only 5% chance that the relationship that we're seeing has occurred by chance. So what's the higher percent there? It didn't occur by chance. There is an actual inherent relationship. And that's why we always look for p-values lower than 10. So that's how we will interpret it. I just wanted to show you how we do these kind of things in Excel. But yeah, that's what you will do. You will use those tools to build those regression models. But that's when your work actually starts. That's when you need to be able to tell that, okay, now let's see what's going on. Now let's see how good or bad this model. If we do that, now it will probably be good. Is it any good now? That's why it wasn't, because this thing wasn't updated. That's why it was always bad. So now that we have got this data, and I've got some random numbers, that's what will give us some random thing. And now I will do data analysis. I will do regression analysis. Yes, I've got Y value is that. We got X value is that. And we've got labels. And I want to do the line fit plot. And let's do this. There we go. Now we have got a really good regression line. Okay, so this is a perfectly fit line. Even we can't even see why. And if we look at the statistics now, this is how it will look like. So the p-value is really less. So it's 10 raised to power negative 83. That's 0.0. So that's now, even if you look at R squared, it will be 1. So this is how a perfect relationship looks like. R squared will be 1 or close to 1. And then this p-value will be close to 0. And if those two are indicating those kind of numbers, that tells you that this is a really good relationship or the regression is a really good fit. Yeah, it probably, it made it a little bit bad, but still you can see the R squared is 0.099, which still means this is a really good fit. And yeah, the X value is really significant. And yeah, we definitely will visit this data analysis toolpak again when we do the statistics, because that's when we will use even more of these functionalities. Like we will use t-test, we will use f-test, we will use, again, descriptive analytics and covariance. We definitely use that. So let's look at correlation. And that looks about right to me. And if we look at the correlation, you can see that they are highly correlated now. You can see that the correlation value is 0.999, which says that the X and Y are perfectly correlated. And that's how we interpret these statistics to find out, yes, these two variables are related, these two variables are not related, and so on. Right. So that's, again, a few examples on how we use data analysis toolpak with all these different things to help our analysis work. And because analysis is not just about getting the data, doing some pivot tables and stuff. You need to do further, deeper analysis. Look at the stats. Look at the distribution. Look at the correlation between variables. Build those linear regressions. Build those forecast models or whatever it is. And that's what we need to be really good at as well.